Hello, my name is Todd Evans, and I am a Level 2 Product Support Engineer at Cole Morgan. And this video series is an introduction to the AKD Ethernet IP servo drive. Welcome to video 7 of the AKD Ethernet IP video series, Ethernet IP Scaling and Units. Ethernet IP units default. It is important for the first time users to understand how Ethernet IP scaling works. The Ethernet IP standard, as means by the ODVA, dictates that the scaling is done in counts for position unit, counts per second, or counts per second squared for position, velocity, and acceleration respectively. It is also important to note while Workbench provides a way to scale the drive in units under the unit screen in the Workbench project tree, those units only pertain to how the units are set or displayed within Workbench. They have nothing to do with how the position, velocity, and acceleration are set, commanded, displayed from the controller, that being the PLC or HMI, etc., using Ethernet IP. From experience, the most intuitive approach is to have the Workbench unit scaled the same as the Ethernet IP scaling, so the counts in the PLC equal the counts set or read in the drive while monitoring within Workbench. When you're online with the AKD under Settings, Communication, Ethernet IP Scaling tab, the default scaling is shown. Position units, 65,536 counts per position unit, and profile units for velocity or acceleration is 65,536 counts per second or counts per second squared. First, let's look at position units. From the above, the default scaling is 65,536 for the EIP.POS UINT. 65,536 can be shown as 2 to the 16th power, so the actual counts per rev of the motor is given by the following formula: 2 to the 32 divided by that setting, the EIP.POS UINT, or if you do the math, 2 to the 32 divided by 2 to the 16th gives you 2 to the 16th, or 65,536 counts. This means if the AKD move block, for example, is programmed with position attribute value 65,536 as in the sample project, when triggered, the motor will make one revolution. Again, this is true regardless of Workbench units. Here's the run from the sample project. You'll note that when you set up the AKD move block, you have an instance name, move type, 0 for absolute or 1 for relative. Then you have XL, decel, speed, and position. All of these values are in Ethernet IP units, again regardless of how Workbench is set up for units. So here's just more details showing the formula for position units and velocity acceleration units. What this means is that in this example block below, the AKD move has a position value, or target position value, 65,536, just 10 times the 65,536 for one revolution. That means that if you were to execute this move, then it would go a relative distance of 10 motor revs. Also note that the 65,536 counts per second is the same as 1 motor rev per second, or 60 RPM. In some cases, the one Ethernet IP count out of 65,536 for rev is not enough resolution for the application. A lot of times it is, but in some cases, particularly if you're working with a DDR motor, for example, sometimes you want higher position resolution or so forth. So in the formula that we're showing here, it's possible to divide the 2 to the 32 by a smaller number, and that is set. If you look below here, that is set by the scaling on the Ethernet IP scaling tab in Workbench. It's also notable that in order for the math to work out to an even number without any repeating decimals or decimal points and so forth, you would need to have your EIP.prof unit set to some value that's 2 to the x. So in this case, the value selected is 2 to the 12th, and you'll notice below that that's 4096. And by using that scaling, then you will achieve 2 to the 20th counts per second in this formula, or possibly 2 to the 20 counts per motor rev for a higher resolution. Keep in mind that we have this in the Getting Started with AKD Ethernet IP guide, and also a PowerPoint presentation that's available on our website that contains this same information. So in this example of a higher resolution, you'll notice that all the units are set to custom on the unit screen of Workbench, and instead of 65,536 counts for motor revved, then we've populated it with the 2 to the 20th counts per one rev. Again, just emphasizing that the values entered should be 2 to the x format, so that there's no rounding or truncation. We consider best practice to set all the units to custom and set the Workbench units to the same as Ethernet IP units, although I have seen some users insist on modeling the mechanics or setting it up for millimeters, inches, and so forth. It is possible to do that, but just keep in mind that the PLC has to still do the math to take the real world units and convert it to Ethernet IP counts. That's what has to be sent over Ethernet IP. So here's an example of the PLC doing the math. Let's say that the HMI, maybe it sets the target distance as 1 inch, and we have a ball screw that has a 0.2 inch per rev lead on it, 5-to-1 gearbox. You want to work from inches per second squared. So here the PLC would do this math and convert 1 inch into the necessary Ethernet IP position counts, and that's what you would populate the, say, AKD move add-on instruction with. And then let's suppose with the same example that you want the move to be 5 inches per second velocity, then here's the math. behind that. To prove a point about units, I'm going to give you a demonstration. The first demonstration, I have the unit set up as recommended for best practices, 65,536 counts per motor rev of workbench units, which is consistent with the scaling, and the formula that we previously covered gives the same resolution of 65,536 counts per rev. So if I go back to the PLC program and I do one index move, relative move, and then I go back to workbench, you'll notice that the distance is what was commanded, and you go to the motion task, and that particular AKD move handle instruction populated it with this data. So in this scenario, the PLC units is consistent with the units in workbench. Let's suppose that I decide not to use the best practices, and let's suppose that for a moment that I'm gonna say that I have a 1-inch ball screw, but I'm gonna work in millimeters. So I have 25/4. So now I've scaled it so that there are 25.4 millimeters per motor rev for the 1-inch ball screw. Okay, so what does this mean? This means now I have position, velocity, acceleration for workbench scaled this way, but the Ethernet IP units really does not care about that. So to give you a demonstration of what would happen if you deviated from best practices and decided to scale it, or possibly use one of these mechanical models in workbench. So recall that we previously gave the motor 65,536 Ethernet IP counts, which is going to be 1 rev. If you notice now with the change in scaling, that based on command to that position, now the feedback position is now at 25.4 millimeters, which makes sense because that's the number of millimeters in 1 rev of the ball screw. So you can see, if I were to do another move with 65,536 Ethernet IP counts, right, the workbench, that you can see that I'm doing multiples of 25.4 millimeters. In this case it's 50.8, which is 2 revs of the motor. So you can see that in this demonstration that regardless of whether you use best practices and make workbench units consistent with Ethernet IP scaling, or you elect to deviate from that, scale it using other units, that you still have to convert real world units in the PLC to Ethernet IP counts, or counts per second squared.